Okay, in this section of 13.3, let's look at the temperature effects of dissolving. So first we're going to look at a gas, and a gas dissolving into a liquid. And the general rule is that the colder the liquid, the more soluble the gas. The colder the liquid, the more soluble the gas. If we zoom in on this figure right here, this is figure 13.16, you can see that we have solubility in millimoles right here. Then we have 1, 2, 3, 4 different gases on there, and then temperature as it goes to the right. And you can see that as the temperature increases to the right, the solubility decreases for just about every single gas. So this is really important if you're an aquatic species that uses oxygen, because you'll find more oxygen in cold water than in hot water. And so therefore fish like trout like cooler water for the most part, because they'll have more dissolved oxygen when the water temperature is lower than when the water temperature is higher. All right, so that's temperature effects for a gas. Now let's take a look at the temperature effects for a solid. And so for this, we're going to scoot over to this diagram right here. And this solubility diagram gives us solids, grams of salt in 100 grams of water right here, and then temperature here on the horizontal axis. So I'm going to make this just a little bit bigger, and then I'm going to change my places right here with this sheet. And for a solid dissolving into a liquid, it's generally, but not always, that you increase the temperature, then you increase the solubility of the solid. And our graph right here that you can see, just about every single one of the curves goes up and to the right, which means that the solubility increases as the temperature increases. So solubility of a number of grams of substance in 100 grams of water goes up as the temperature goes up. I'm going to turn this just a little bit, and then we're going to go through a few trick questions that are usually associated with reading graphs like this. First of all, the number one thing that you want to look at is the axes. You want to look at the vertical and the horizontal axes to know exactly what they're asking about, or exactly what the graph is showing you. And notice this is solubility, so that's the number of grams of a salt that will dissolve in 100 grams of water. So remember, it's always based on 100 grams of water. So if you have a beaker, know that the beaker is going to have 100 grams of H2O in it, and then you're going to put the salt in there. Now, if they tell you the beaker has 200 grams of water, remember everything's going to be doubled, because then there's going to be double the amount of solvent that can do the dissolving. All right, so with those there, let's go through a few quick trick type questions that can come from reading a graph like this. First of all, here's the rough outline of the question. What is the maximum grams of KNO3 that can dissolve in 200 grams of H2O at 20 degrees Celsius? So first of all, KNO3, so you got to find the right curve. So here's KNO3 right here. I believe that's kind of greenish in color. And then it says that it's at 20 degrees Celsius. So 20 degrees Celsius would be right here. And if we follow up, we hit the line at the maximum solubility for KNO3 at 20 degrees Celsius. And it turns out that in 100 grams of water, you could dissolve 30 grams. See, the 30 right here goes over to the green line. And so you could have 30 grams of salt in 100 grams of water. But watch out, this is a trick question, because it says how much could dissolve in 200 grams of water. Well, in 100 grams of water, we could dissolve 30, so double it, so you could dissolve 60 grams because it's in 200 grams. So see how there's a tricky part to it? You got to make sure that you read over here how much you dissolved. Second question is kind of multiple choice, and so I'll go through the answers first. The answers would be supersaturated, saturated, or unsaturated, okay? And it wants to know, what is the solution? The solution, remember, that's the liquid part of the stuff inside of a beaker or inside of a container. So then it goes through and it says, in 100 grams of H2O, oh good, we know it's 100 grams right here, of KClO3, what kind of solution would we have if we had 10 grams of KClO3 dissolved in there? So let's find our KClO3 first. It's right here. Okay. And we happen to be at let's see, the 100 grams of H2O, we know it's KClO3, and I believe this is going to ask at 30 degrees Celsius, so let's put that in there as well. So at 30 degrees Celsius, it looks like we can go up and we can dissolve 10 grams of this salt at 30 degrees Celsius. So KClO3 would be saturated at 30 degrees Celsius right now if I dissolve 10 grams in there. And so letter A, I'd have a saturated solution. All right, letter B, now if I put 30 grams of this KClO3 in there, well, I'd be way up here. I'd have too much of it to all be dissolved. Now be careful how they ask the question though, because they said in the solution. And so inside of your beaker, you'd have 100 grams of water, and then you would have put 30 grams of the salt. Now, 10 grams of that right here would have dissolved in the solution. So you'd have 10 grams dissolved. You'd have an additional 20 grams sitting down here at the bottom of the beaker, not dissolved. So if they're asking the question, what kind of solution is it? You know, the liquid part right here, you'd say the solution is saturated. Now we have extra solute sitting at the bottom, but it is not supersaturated because it didn't say they did something special like heat it way up and then cool it down and more dissolved than it's supposed to. They didn't say that. They just asked what kind of solution it is. Now the third question, 50 grams, that'd be the same thing. So if you were way up here, you'd have, at this spot, 50 down to 10, you'd have 40 grams sitting at the bottom of the beaker right here, and then you'd have 10 grams that would be dissolved. And once again, it would be another saturated solution if they were asking about the solution. If they asked how many grams would be dissolved and how many would be sitting at the bottom of the container, I answered those for you as well. Last trick question. If 100 grams of solution, we had 100 grams of solution of 40 grams K2CrO27 in 100 grams of H2O, and we cooled it from 80 to 40 degrees Celsius, what mass of K2Cr2O7 is dissolved, and what mass of K2Cr2O7 is solid? Okay, so it's good we know we have 100 grams of H2O, and we have 40 grams of the K2CrO7. So follow that over here, and the K2CrO7 is this line right here, and follow that all the way over until we get to 80 right here. So at 80 degrees right here, we would have, let's see, I could dissolve up to about 50, oh, that's probably about like 58 grams. But I only have 40 grams in there. So at this point, the mass of Cr2O7 is 40 grams that are dissolved. So at this point, there are 40 grams that are dissolved. I could dissolve more, but at that point, I have 40 grams dissolved. Now, if I cool it from here all the way down to 40 degrees, so way down to here, now I can see that at 40 degrees Celsius, I'm well above this line. As a matter of fact, maybe like 18 grams right here would have had to be precipitated or fallen to the bottom of the beaker. And so at this point, at 40 degrees, I'd still have my 100 grams of water. And inside of there, at 40 degrees, I could have like 22 grams that are dissolved. And then the remainder of it, that 18 grams would have to sit at the bottom of the beaker, and that would be like a precipitate or a solid down there. Now the solution would still be saturated. It's just a matter of I'd have some solid in contact with dissolved solute in here. All right, there's some good examples of some trick questions along with temperature effects of solubility.